Welcome everybody. Today we're working on the James Stewart edition calculus book, Early Transcendental. Today we're working on a problem that deals with polar coordinates. Okay. This guy is Michael Zarate and he'll lead the way. Introduce yourself, please.
Hi, I am Michael Zarate.
The problem says the following. Find the area of the region that lies inside both curves. R equals 1 plus cosine theta, and R equals 1 minus cosine theta. Take it away, Mr. Zarate.
We need to see the graph for these two problems. So we'll graph R equals 1 plus cos theta first. And it's going to start from 0. You plug this into the equation. Theta equals 0. So then cos of 0 is 1, and 1 plus 1 is 2. So then we're going to just do it from 2. 1, 2. We'll start the graph from here. We'll go to pi over 2. So then 1 looks something like that. And once you reach pi, and you plug pi into there, it's going to be 1 plus negative 1, which is 0. So it's going to come back down to here. So it's going to come around, and it's going to curve down. And we'll come back around. Once it reaches to 3 pi over 2, it's going to be 1 again. It's going to come back down like this. It's going to go all the way back to 2 over pi. It's going to look like a heart, kind of. If you do it on your graphing calculator, it's going to kind of look like a circle, because this is just my sketch so far. So now we're going to graph, well, here, I'll label it for you. R equals 1 plus cos theta. Oops, I spelled cos wrong. Cos theta. Now we're going to graph R equals 1 minus cos theta. So if we plug in 0, it's going to be 1 minus 1, which is 0. So it's going to start from 0 and come back to pi over 2 at 1. It's going to go to pi at 2. Come back down to 1, and then go all the way around back to 0. And this is kind of how the graph will look like. They should be equal graphs. Like that. 1 minus cos theta. And now we are going to look for the limits of the region. So the limits will be at the intersecting points. Let me get a different marker for you. Will be at the intersecting point, which is here and here. This one doesn't count because this is just a polar coordinate. So in order to find these points, we're going to have to equal the r's to each other. So it's going to be 1 minus cos theta equals 1 plus cos theta. So then we subtract the 1, minus 1, minus 1. The 1's cancel out. Now it's going to be negative cos theta equals cos theta. Now we add cos. Now it's going to be 0 equals 2 cos theta. Now we divide by 2, divide by 2. So cos theta equals 0. And from here you'll get theta equals pi over 2 and 3 pi over 2. Which are these points right here? This is 3 pi over 2 and this is pi over 2. Now from here, we have to find the region that lies in both graphs, which is here, here, here. And now by looking at the graph, we're trying to get this whole area. So it would be easier for us if we just cut it in half. Cut it down the middle. And as you can see, if we take 1 plus cos from pi over 2 to 3 pi over 2, it'll just be from here all the way down. It will be from here all the way down to here. So that now we are going to use the polar area formula from pi over 2 to 3 pi over 2 1/2 r squared d theta. And in this case, since we're cutting it in half, we have to multiply it by 2 in order to get the whole formula, in order to get the whole area. So multiply this times 2. So now we're going to plug in for r, we're going to plug in 1 plus cos theta, because as you can see, r equals 1 plus cos theta. This graph from pi over 2 to 3 pi over 2 gets the area that lies between both curves. So now it's going to be 2, we're going to bring out the 1/2. Oh, it's not. 3 pi over 2 pi over 2 times 1 plus cos theta squared d theta. So we're going to have to cross, these cancel out each other. Oh, equals 1. So then now we're just going to bring it down. We're going to multiply this. It's going to be 1 plus 2 cos theta plus cos squared theta d theta. And then from here, we're going to take the cos squared theta, 2 cos squared theta minus 1 equals cos 2 theta. That's what the half angle formula is going to equal. So we just add the 1 to both sides. And we divide by 2. And this is what we're going to substitute for cos squared. So we're going to plug that into there. So I'm going to go from 3 pi over 2 to pi over 2. 1 plus 2 cos theta plus 1/2 plus cos 2 theta over 2 d theta. And we're going to add these two together since they're common factors. It's going to be 3 over 2 plus 2 cos theta plus cos 2 theta over 2 d theta. And now we're going to integrate. So 3 over 2 theta plus 2 sine theta plus sine 2 theta over 2 times 1/2. Because the integration of cos 2 theta is sine 2 theta over 2. That's what the integration just for this. Then you have to multiply it to the half. That's already applied to it. That's that. Now then it's going to go from 3 pi over 2 to pi over 2. Now we have to plug in the limits. So it's going to be 3 over 2 times 3 pi over 2 plus 2 sine 3 pi over 2 plus sine 2 times 3 pi over 2 divided by 4. This time it is not my phone, so we do not need to worry about that. Now, minus the higher limit minus the lower limit. It's going to be 3 over 2 times pi over 2 plus 2 sine pi over 2 plus sine 2 times pi over 2 divided by 4. When we multiply them out, now it's going to be 9 pi over 4 plus 2 times sine 3 pi over 2 equals negative 1 plus, so when you multiply these twos cancel out, and it's going to be sine 3 pi. Sine of 3 pi, which is 0. So it's going to be 0 over 4, which is 0. And you're going to subtract lower limit. Now it's going to be 3 pi over 4 plus sine of pi over 2 is 1, so it's going to be 2 times 1 plus, when you multiply these two out, it's going to be sine of pi, which is just 0 as well. Now we're going to add them, distributing the negative sign into this. Now it's going to be 9 pi over 4 minus 2 minus 3 pi over 4 minus 2. So 9 pi over 4 minus 3 pi over 4 equals 6 pi over 4. And when you subtract the 2, or add the 2's, I guess, it's going to be negative 4. And we can reduce the 6 pi over 4. It's going to be 3 pi over 2 minus 4. And that will be your final answer for this equation. Thank you. Good luck.